So we've looked at the phase shift of the sine and cosine. Here I've got an example of just the cosine of x, very basic, just kind of drawn out some of the key points. And we've looked at the phase shift, the period, the amplitude, some reflections. But now we're going to look at another aspect called the vertical shift. A vertical shift in any graph, just adding or subtracting to the function value of all the points, can be done simply by adding or subtracting a value to the output of this function. Okay, so if you think about this for a moment, if you were to, let's say you take this one wavelength of the cosine, if you wanted to shift everything up by, say, half a unit, by 1/2, right? Then this maximum comes up by 1/2, this minimum comes up by 1/2, everything comes up by 1/2, the whole graph raises up. And essentially all you're doing is you're taking all the outputs from the cosine and just adding 1/2. Add a number, add a number, add a number, add a number, and everything shifts up, okay? All the outputs shift up. And so the y values then rise. Okay, and so what you end up with is just simply adding a number, we're going to call it c, outside of the cosine or the sine. It could be the sine too. I'm just using the cosine because I've dealt with so much with the sine in these videos. So to raise the value or to drop it, dropping it would be subtracting a constant. You just go with a plus c. Now that c could be positive, which raises it up, or I guess instead of subtracting, you could add a negative c and that would drop it down. Okay? So an example might be y equals the cosine of x plus 3. Okay? And so this one's just kind of a basic graph, starting with the basic cosine. We know the period. I know my 5 key points. All I really have to do is get my graph shifted up 3 units. Well, to shift it up, I need the maximum to go from 1 to 4, the minimum to go from -1 to 2, and the axis here to go from 0 up to 3. So when I plot these with the shift, let me redraw that. I'm going to start by, I'll put my y-axis in. I'm going to put my y-axis low on the graph because I know this is a shift up. There's my, I'm sorry, my x-axis, I said y. My x-axis should be low. Then we're going to shift up 3 units, but then remember that's really just shifting the axis up 3 units, right? So 1, 2, 3. And I'm going to draw in kind of a dashed line. Okay, so that's essentially the new axis for the center axis for that cosine. Our amplitude isn't any different, it's still 1. Okay, so my amplitude being 1 means from that axis you go up 1, down 1 to get the max and the min. So 1, 2, 3, and 4. So the maximum then is going to be up at 4. And the minimum is going to be down at 2. Now I like to draw in these dashed lines just because it helps me to visualize where everything goes and really get everything lined up, all the points. Now on my x-axis, I want to make sure to get my 5 key points. Now with the regular cosine, there's no phase shift, there's no period change. I'm going to keep those the same. So we're going to go over to 2 pi. Just put that on there, and then I need to cut that in half to get the pi in the middle, quarter to get pi over 2, and a third quarter to get, what's that, 3 pi over 2. Yep. Okay, and then I can sketch in my points. So again, we start at the max with the cosine. Then at the first quarter point will be at the axis. No, it's not the x-axis anymore, it's just the axis, the horizontal axis in the middle. Then at the halfway point, we're down to the minimum, Then we go back up to the axis at the 3/4 point, and at the full period, we're all the way back up to the top. Okay, hoping those line up pretty well. Again, they almost look like a V shape. Those 5 points are currently in a V shape. You could connect them with lines, but we don't want lines. We don't want lines for a cosine. We want it to be a nice smooth curve. Okay, so we're going to draw that curve through the 5 points. That's not too bad. Looks pretty good. Okay. Now, I would probably go ahead and put ordered pairs on each of these just to make sure that it's clear where each of these points are. So here we have 0, 4. The next one here would be pi over 2, 3. And then pi, 2. This would be 3 pi over 2, 3. And 2 pi, 4. Okay, so that gives me all 5 of my key points on the graph. Again, you could extend this simply by adding another half pi or subtracting another half pi repeatedly to map out more periods of the graph. Okay. Okay, so that gives you the idea of a vertical shift. As a general rule then, this C value, C is the vertical shift. And of course, when C is positive or greater than 0, that shift will be up. And when the C value is less than 0 or negative, that shift will be down. But that C value, that constant that's being added on the end, will always give you a shift. It will shift every point the same. Okay, so the maxes, the mins, the intercepts, everything shifts around the same unit vertically. Okay. Now we can really put all of these ideas together: the phase shift, the vertical shift, the period and the amplitude, the reflections, and look at a graph that has all of those sorts of transformations associated with them.